Okay, so today we're going to do polynomial area problems. And here's the first place I want to start out, is not with any polynomials. I guess you could say these are constant monomials, but I just want to start with like a basic example. Let's say I was given this shape, and I want to find the area that I've just shaded in blue. Assuming that like I don't have these white spaces here, but like this entire kind of area of this rectangle in blue. How might I find that area? Well, I have the area of the big shape, which is that I can find the area of the big shape very easily, which is this portion right here, by taking 4 times 5, but that would give me everything. That would literally give me every part of that. But there's a part that I don't want. I don't want this cutout shape, but maybe I can find that area too by doing 2 times 3. And then if I want everything except that shape, how could I take the area of the total, which we found, which is 20, and the area of this inside part, which we found, which is 6, and figure out what the area is in blue? Well, if this is the entire thing and this is the part I don't want, if I just subtract that, I would get 14. And that's the area in blue. We're going to do that today in a couple different contexts. And a lot of the word problems will kind of work out this way. The first thing that you need to do, though, is keep this picture in mind. Because we're going to come back to this picture a couple times and think through that. And we're going to need a skill set. We're going to need the skill set of being able to multiply two polynomials together and then subtract them and find what an answer is. So that's the first thing that we're going to do. So we're going to look at a problem where we have already been given the polynomials and we just need to subtract them. Okay, so here's the setup. And again, I want you to think about this as the bigger box. And this is the smaller box. And we are going to multiply this thing together, right here, and this thing together, and then subtract them. So hopefully you remember how to multiply these polynomials, which means I just have to distribute them right there and get x squared plus 3x, and then distribute this 4 and get plus 4x plus 12. And I'm going to keep this in parentheses because I want to combine some stuff. Then we're going to subtract it from this side here. I would want to distribute that x, and I would get x squared plus 2x. That equals 48. Now what I would want to do is I would want to combine like terms over here. So I get x squared plus 7x plus 12 minus x squared plus 2x equals 48. Now if you remember before, subtracting polynomials, it's always easier to add, and how I can make this an adding spot is taking that negative and distributing it to both things over there, which would give me negative x squared and negative 2x. And then I would combine like terms. So that will cancel with that. That will cancel with that and become 5. So we'll get 5x plus 12 is equal to 48. I would subtract 12. I'd subtract 12. That's going to give me that 5x is equal to 36. Then we would just have to divide this. So, whoops. I'd have to divide the 5 and the 36. And that's going to be about 7. So like 7.2. And if it doesn't come out to be a whole number, you can round it to be decimal or just leave it as that fraction. Today's problems that I created for you should all turn out to be whole numbers. Let's look at how a word problem might be set up now. Alright, okay, let's say I've been given this image, and they go, okay, the area of this thing is 100, let's let's say centimeters squared for this shaded region. So this shaded region in here, which might be a little bit hard to see, but it's this outer region. And I need to figure out what x is. Well, again, it would really be nice because I can find the area of the entire thing in yellow by doing 2x times 3x minus 2. And I can find the area of this blue inside part by doing x minus 1 times x plus 3. And how I could find that area that I want just in green is I could subtract the two. So we're just going to do that, and we go, okay, the area of green made the whole thing equal 100. So that just looks like the problem that we just did a second ago. But we'll start doing this problem. So we kind of go, okay, distribute. So 6x squared minus 4x. And again, I want to keep that in parentheses just for a second. Then we'll distribute this, which will give me x squared plus 3x minus 1x minus 3. Then I'm going to go, okay, what's easier than subtracting? Oh, distributing this and adding. I should also probably combine that before I do that. So I got a little bit ahead of myself. So we'll get 6x squared minus 4x. Let's combine that and give me 2x. So then I get negative x squared minus 2x minus 3 is equal to 100. We can then cancel like terms. That is going to go out and cancel with this. So I get 5x squared. This will cancel with this. Well, combines to become negative 6x. And then I'll get negative 3, and that equals 100. And then at this spot, I'm going to stop because my x squareds didn't all cancel. Today, the box problems that you're going to be given, all these x squared should cancel out. So they should all go away. In this case, we just didn't have that happen, so we are actually stuck and not able to solve. But most of them will solve out just like we did the first example today. Let's do one last problem where they don't give us the box. So if they don't even give us the box, and we kind of had to write it up. Okay, so let's try to take all our skills together today and combine them and find out the answer to this word problem. So suppose you're designing a rectangular garden. The length is twice the width. You want a walk 2 feet wide around the garden. And so suppose the area of the walk is 136 feet. Find the width of the garden. Okay, so that's a lot of pieces of information. Here's my recommendation. For all of these things, the first thing you need to do is draw a picture of what you are trying to make. So we wanted a rectangular garden, and we had some width that we don't know. We know that the length is twice the width. So if I take the width and I double it, that's my length, which is right here. And then after that, we said, hey, we wanted a sidewalk. So here's my garden on the inside in green. I wanted a sidewalk to go around this thing. Whoops, not the best drawer. But the sidewalk, I said, hey, this needs to be 2 feet. Like that needs to be 2 feet at any spot. So that's 2 feet. The sidewalk gives you an extra 2 feet of width. And we know that the entire sidewalk, if you take this right in here in yellow, that entire sidewalk is going to be 136 feet. So let me try to draw this a little bit better again to make it a little less messy. But we know from here to here that's 2 feet. We know that this is going to be 2w, and this is going to be w, and we want to find this w. Well, again, It's pretty much like all the problems before. We can figure out the area of this entire thing by figuring out what this would be. Well, this thing has 2 feet here and 2 feet here, so it's at least 4 feet plus this. So this entire side right here would be 2w plus 4 feet. This big long side right here. And we could also figure out the width of this thing, because the width would have a 2 foot here and a 2 foot here, so this would just be w plus 4 feet. And then we can find the inside portion, because the inside portion would just be w and 2 feet. So we're going to do the exact same setup we did before. So if we do 2w plus 4 times w plus 4, and then we subtract the inside portion, which would be w and 2w, what we can do is we know that that's going to equal our entire inside portion from over there, which our entire inside portion is 136 feet. And again, it just becomes the problem like before. So we just have to multiply two polynomials together and then solve. So distribute, distribute. I would have 2w squared plus 8w, distribute, distribute, plus 4w plus 16, distribute, which this one's really easy to distribute, because I get 2w squared. It's again in parentheses, and then that would equal 136. We can cancel that with that right away. That would just become 12w plus 16 is equal to 136. Subtract the 16, subtract the 16. I would have 12w equals 120. Divide by 12, divide by 12. W equals 10. So we just found the width to be 10. And that would answer all my questions. Here's the big thing. Again, you want to draw the picture. Most times for these pictures, it's going to be some kind of area on the inside being taken away from some kind of bigger area. We could have other problems that make the two things equal, or a couple other different situations. Just like try to read through the problem and see kind of where it's asking, and try to set up the word problem similar to this.